Today's lesson is on imaginary and complex numbers. A little bit of background on imaginary numbers. They do exist. They can be found when working with quadratic functions, and we use the letter I. They're used in such areas as signal processing, control theory, electromagnetism, quantum mechanics, circuit design, and cartography. When we think about imaginary numbers, we think about, can you always find roots for the equation x squared minus 1 equals 0? It has no real solutions because x squared would equal negative 1 and x would be the square root of 1, as seen right here. You call the solution to the above equation the imaginary number. It's also called I. The number I can be referred to as J if you're studying electrical engineering. Imaginary numbers are there to ensure that all polynomials will have roots. The definition of pure imaginary numbers. Any positive real number b can be broken up to, if you have the square root of negative b squared, right there, you can break that up into the square root of b squared times the square root of negative 1. And if we remember, the square root of negative 1 is also referred to as I, and the square root of b squared is b. So therefore, you will get bi. So the definition of pure imaginary numbers is that I is equal to the square root of negative 1, and I squared, if you square both sides, I squared will equal negative 1. So things to remember would be that I is not a variable. It's a symbol for a specific number because I is the square root of negative 1. And it allows us to take the square root of negative numbers. So let's go through and see if you can simplify each expression. This would be a good time to hit pause, try it yourself, and then see if you get the same answers that I do. Let's try number 1. The square root of negative 81. You will break that down into the square root of 81 times the square root of negative 1. And if you remember, the square root of 81 is just 9, and the square root of negative 1 is I. So your final answer is 9i. To complete number 2, you're going to look at the square root of negative 121. So the square root of negative 121 is also referred to as the square root of 121 times the square root of negative 1. If you think back, the square root of 121 is 11, and the square root of negative 1, as we talked about, is I. So your final answer is 11i. The next one is the square root of negative 200. 200 is just really the square root of 100 times 2. So that negative is going to give you the I, the 100 will give you the 10, and then the square root of 2 stays inside. So you'll rewrite that as 10i rad 2. So now we're going to go through and simplify each expression. As I said before, you may want to hit pause, try these yourself, and then come back. Okay, to continue, number 4. First, you would just multiply the numbers 8 and 3, so you get 24. I times I is going to be I squared. Now, what might you have to remember about this? Can you simplify it at all? What do we know that if I is equal to negative 1, I squared is equal to what? So your I squared is equal to negative 1. So then this just becomes 24 times negative 1, so you should get negative 24. Going to example 5, I'll give yourself a little bit more room. You have the square root of negative 5 times the square root of negative 20. So now you have the square root of negative 5 times the square root of negative 20. At first you might think that you could go through and type that in as the square root of 100. But unfortunately, we have to take care of the negative square roots first, so that will not work. So what we have to do is we're going to call this I rad 5 times I rad 20, because the I comes from when it's a square root of negative 1. So then I times I will give me I squared, and underneath the rad I have 5 times 5 times 4. The two 5's come out, you'll have 1 5 come out. The 4 square root of 4 is 2, so your final answer is going to be 10 times I squared. Now remember, I squared is just equal to negative 1, so your final answer is negative 10. Now let's talk about the cycle of I. I to the 0 power is the same as anything to the 0 power, it's just going to be 1. I to the first power is still going to be I. We know that I squared is negative 1. So now we can build all our other ones based off of that. So I cubed is the same thing as me saying it's I squared times I. So the I squared is negative 1 and I is just I. So I cubed is negative I. So continuing on, I to the 5th, you could break this down and make it easier for yourself. Call it I to the 4th times I. And I to the 4th is 1 times I will just give you I. I to the 6th can become I to the 4th times I squared. So that's 1 times negative 1, you will get negative 1. I to the 7th is I to the 4th times I cubed. So that's 1 times negative I. And that gives you negative I. So you see the pattern will start to go around and around. So when you simplify, if we're trying to figure out I to the 12th, you go figure out where we are in the cycle that you are and divide the exponent by 4. So you're going to look at the remainder. So I to the 12th is just divide by 4, you get 3 with a remainder of nothing, which is just I to the 4th times I to the 4th times I to the 4th. Same thing as me saying I to the 0, because this is your now remainder. And I to the 0 is 1. I to the 11th, we take 11, we're going to divide that by 4, and you're going to get 2 with a remainder of 3. We're going to use that remainder, so that means that I'm going to get 2I to the 4th, and I to the 4th times I to the 4th is I to the 8th, and then that gives me an I cubed. Now I know that I to the 4th is 1 times 1, and I cubed is the same thing as me saying negative I. So therefore my answer is negative I. I to the 17th. You can take 17 divided by 4 and you will get 4 with a remainder of 1. So that means I make 4 cycles of I to the 4th. Instead of writing I to the 4th 4 times, I can just write it to a power of 4 times 1 additional I for that I to the 1. The remainder is the 1. I to the 4th is 1, and I is just I. And anything, 1 to the 4th power is just going to be 1. I will be I, so therefore your answer is I. I to the 26 goes in 26 divided by 4 is going to be 6 with a remainder of 2. Because 4 times 6 is 24, and then you have 2 more to get to 26. So that would be I to the 4th to the 6th power times I squared. So therefore, this becomes 1 to the 6th, and I squared is negative 1. So 1 times negative 1 is just negative 1. The definition of complex numbers. Any number that's in the form of a plus bi, where a and b are real numbers, and I is the imaginary unit. So the real part of the number is a, and the imaginary part of the number is bi. When adding or subtracting complex numbers, you just combine the like terms. So you really do essentially treat the I like it's a variable. So you're doing 8 plus 2 is where we get this from, and that's 10. And then negative 3i plus 5i gives us positive 2i. Going through another example, you're just going to go 8 plus negative 12 is negative 4. And 7i plus 11i is 18i. It's that easy. Don't overcomplicate it. Make it simple for yourself. The only thing you have to remember on this problem is that you have a negative. So treat that as a negative 1 and distribute. So now why don't you take a minute and try to do this problem. When you're ready, press play again and we'll see if you get the right answer. Okay, so hopefully you'll get the same answer that I do. You should have 9 minus 6i. Distributing the negative gives you minus 12 minus 2i. I'll put the 9 minus 12 together to get my negative 3. And then my negative 6i and the negative 2i will make negative 8i. And that is your final answer. So to multiply complex numbers, you just use the same procedure as multiplying polynomials. So you can FOIL. So why don't you go through and see if you can FOIL this out. Okay, so to get the f, you'll do negative 6 times 5, which gives you negative 30. The o is from negative 6 times negative 3i, so that's my plus 18i. Inside times inside is 2i times 5, that's plus 10i. And then last times last will get me negative 6i squared. You want to go through and see if you can simplify anything. We will go through and simplify this. However, we want to just make sure we address the I squared. If you remember, I squared is equal to negative 1. So that gives me negative 30 plus 28i, and negative 6 times negative 1 is plus 6. So your answer will be negative 30 plus 6, negative 24, plus 28i. This is our last example. Thank you for sticking through it with me. So please try it and press play when you're ready to go through the answer. Okay, so hopefully you're ready and you've already done it. If you go through, I'm going to do first times first is 16. Outside times outside is negative 24i. Inside times inside gives me plus 10i. And last times last gives me minus 15i squared. Going through that, I get 16. This gives me negative 14i. And this will give me plus 15. Because if you remember, the I squared is equal to negative 1. So you'll have negative 15 times negative 1. So our final answer, if you add those two, you'll have 31 minus 14i. Thank you so much, and I'll see you in class tomorrow.